Section 8.5 is going to be relatively quick, and here's why. Although it's about word problems, it's about word problems that produce a system of equations, and we studied that sort of word problem before back in Algebra 1. The only real difference was, in Algebra 1, you would only study 2 equations and 2 variables word problems. These word problems will allow for more variables and more equations. But the basic idea of translating from a paragraph into a system of equations, that technique really isn't going to be different now. It'll just take a little bit more work to set up and a little bit more work to solve. So there's a good chance that if you understood that topic back in Algebra 1, you'll probably understand it here as well. So let's talk about how to work through a problem like this just to make sure that you see how it translates into 3 equations and 3 variables. So the first thing you should do is identify what your variables are. And the easiest way to do that is to read through the paragraph, find out where you're being asked to find something. What's the actual question about? And here the question is about how many servings of each need to be included in the meal for the patient. And when they say each, what they mean is each servings of roast beef, baked potatoes, and asparagus. So X is going to be the number of servings of one of those things. So the first one is roast beef. Y will be the number of servings of the next one. In this case, baked potatoes. And Z will be the number of servings of the third one. Notice that there really didn't have to be exactly 3 of these. It could very well have been 4, or 5, or 6, or 7. When you go into an actual kitchen at an actual hospital, there's probably a couple of dozen different food choices available. So the number of variables here, realize 2 variables back in Algebra 1 and 3 variables right now could easily grow to be 4 or 5, and all that's going to do is increase the length of time it takes to solve without changing any of the techniques any. Next, if we have 3 variables, we're going to need to have 3 equations. If you have 4 variables, you'll need to have 4 equations. If you have 5 variables, you'll need to have 5 equations, and so on. So here, the equations come from things that have to come out equal to a particular result. That's kind of how an equation works. Something equals something else. And the stuff that has to come out equal to a particular result are the number of calories, they have to be 800, the number of grams of protein, have to be 55 grams of protein, and the amount of vitamin C. There's got to be 236 milligrams of vitamin C. So the 3 equations we're going to get, they're going to be a calories equation, a protein equation, and a vitamin C equation. So read the whole paragraph thinking of those things one at a time. So read the paragraph thinking calories. So read, calories, calories, calories. Roast beef provides 300 calories per serving. And we're going to have X servings of roast beef. So 300 times X, that's how many calories we get from roast beef. Baked potato provides 100 calories per serving. And we're going to have Y servings of baked potato. So 100 times Y, that's the number of calories that come from baked potato. And asparagus only provides 50 calories a serving. And there are Z servings of asparagus. And the calories all together have to equal out to 800 calories. Now once you see how that equation gets built, you can probably build the other 2 equations in a very similar fashion. Protein's got to add up to 55. Each serving of baked potato provides 20 grams. Sorry, that was roast beef. Each serving of roast beef provides 20 grams of protein. Each serving of baked potato provides 5 grams of protein. Each serving of asparagus provides 5 grams of protein. So there's the protein equation. And then you've got your vitamin C equation. It's got to equal 236. Each serving of roast beef provides no vitamin C at all. That's kind of interesting. Well, here's what you do. You could either say 0 times x, or just don't write the x part at all. I mean, 0 times x is the same as 0, so you could just leave that part out entirely. Baked potato provides 20 milligrams of vitamin C per serving, and asparagus provides 44 milligrams of vitamin C per serving. And look, we've built 3 equations. We had 3 variables, we built 3 equations, so now you're set up to just solve the system of equations. So I'm not going to work through the details of solving it. You probably want to pause and try working it yourself, but let me give you a hint first. If you're struggling at all, one thing I would suggest you do is simplify these equations first. Like the top equation, you could divide everything by 50 and make the numbers a lot smaller. Second equation, you could divide everything by 5 and the numbers will be a lot smaller. The third equation, you could divide everything, looks like 4, 8, no, only 4. Divide everything by 4. The other hint that I'll give you is the bottom equation doesn't have x in it. It's only got y and z. So a smart way to approach this problem is to take the top 2 equations and somehow or other get rid of x. So the blue and the green equation would combine to make a yz equation, and you already have a yz equation for the third equation, and then you'd have 2 equations with the 2 variables y and z. You could solve that. So go ahead and press pause, try solving the system of equations, and then I'll tell you what the answer is, see if you got it right. So the answer we get out of this when you're all done is that the patient should get 1 serving of roast beef. They should get 3 servings of baked potato. And they should get 4 servings of asparagus. It's a hospital. Of course, they're going to feed you a lot of vegetables, right? And let me ask you something here, just to consider. Is it possible to have a problem like this where the answers come out to be fractions? And it sort of depends what the type of word problem is. In this word problem, sure, you can have half a serving of baked potato pretty easily. You could have a third of a serving of roast beef, no problem. So fraction answers would make sense here. But in some situations, fraction answers don't make sense at all. Like if you're talking about a number of things, like people or dogs and cats, or something where you can't really have fractional items. So there are some situations where you expect the answers to come out to be whole numbers, like we kind of did here, but fractions are a possibility. The same sort of thing goes with negative numbers in your answers. Here, in this particular problem, it wouldn't make any sense to, say, have a -3 servings of roast beef. So you expect these answers to come out positive, maybe 0. Maybe you're not allowed to have any baked potatoes or something, but not negative. Negative wouldn't make any sense at all for this word problem. But there are some situations in which negative answers are possible. Like if you're talking about how much profit your company makes. Your company can make negative profit. That's bad. That's loss, but it happens. So when you get the answers to problems like this, always do sort of a common sense check. Does this answer seem even rational at all? And in this case, yeah, these numbers all seem pretty reasonable. That's a lot of asparagus and just kind of a bit of baked potato and just a little bit of roast beef, and I might not be happy to eat that meal, but at least it's a reasonable meal. It's not something that is like inhumanly large numbers or almost nothing. It's all reasonable for an answer. So when you're setting these problems up, use the same techniques from Algebra 1. You will end up with a larger system of equations, not 2 and 2, but probably 3 and 3. Solve it, and then of course do a common sense check at the end.